Hello, welcome to this lesson where we're going to go over factorising. Now, some of this is revision from last year and some of it is a bit of a new idea. So bear with me, there's a few examples and there's a few questions for you to do. Now, it's important for us to remember that we have factorising and expanding, and they're really the opposite things. So factorising, you could remember it as unexpanding. That's not a formal definition, but it's a easy enough one to use. So we can remember that we're just doing the exact opposite thing as we were doing when we're expanding. With the first two examples, they're things that you've looked at in previous years. What we're trying to do is we're trying to take the highest common factor and pull it out the front. So we're going to have a number and then some brackets with some things in the middle. So I look at this and I straight away see that there's two numbers which are divisible by 3. So I'm going to take a 3 out the front. Now there's more I could do here, but just for the sake of the example, I'm going to stop there. So if we divide this number then by 3, which we've taken out, we get 5 p squared q cubed. Then we divide the second number by 3, and we're going to get 4 p q4. Now this could be considered a step of a partially factorized. So this is only partially. And that just means that yes, it has been factorized, but there's more steps we could take. When you're in an assessment or using these skills in everyday life, you're trying to factorize as much as possible, because that then helps us to simplify what's happening in the brackets as much as we can. Now, we can also take out some algebraic terms here. So we'll keep our 3, but we can then take out, there's 1 p there, so that's the most p's we can take out. And then we have q cubed and q4, or q to the power of 4. So we can take out the biggest number that we have there. So that's q cubed. So now we want to then be dividing these two numbers by that. So we're going to keep our 5, and our p is now divided by that one. P squared becomes p. And we've lost our q cubed because it's been pulled out the front. Now we have 4, we've lost our p, and our q to the power of 4 becomes q to the power of 1, which we can just write as q. So this is our fully factorized. So here we had a partially factorized and now it's completely factorized solution. Next question, exactly the same. There's more terms there, but it's the same process. We're looking for the highest common factor in all of these. Now, I like to look at the numbers and then the algebra. So if we look at the numbers, we have 21, 3, and 9, and I know that all of those divide by 3. If you don't know how to do this, and this is something that should come to you naturally, you need to be practicing your multiplication times tables, as well as potentially using factor trees to find these things. But our highest common factor here is going to have the number 3 in it. We also want to look then at the algebraic terms. We want to look at the biggest number that is in all of them. So because of this term, which has an x, there is an x in each of the others, but we can't use anything else. So we're going to take our x out. So now we need to just divide each term by the highest common factor, which we've pulled out. So we're going to get 7y minus 1, because this whole thing's divided by itself, and then we're going to get 3 and then an x, because 9x divided by 3x is going to be 9 divided by 3, which is 3, x squared divided by x, which is x. The next two questions are new, and they seem a bit confusing perhaps at first, but they're really not too difficult. What we notice here is we have two shapes of numbers that are very similar. Sorry about that. If we look here, we notice that we have an x minus y, and again an x minus y, and then we have a 3 here, an a and an a. So there's something that we can do here. There's a similar pattern in this one, and this one. We're going to have this time an a common in both of those, and a c common in both of these, and then 2b, then plus x, plus x. This is important when we look at the next step. So our next step is we're going to just break this into two parts. So I'm going to very simply put some brackets around these ones, because we can always add brackets when we're adding and subtracting. Okay, so far we've done nothing, but we can look at each of these individually and see how could we factorize them. In this one we have a common factor of 3, and here we have a common factor of a. So we're going to get 3x minus y plus a x minus y. Now, because we have 3 of this plus a of this and they're both the same, we can change this into 3 plus a lots of x plus y. Please do let me know if you didn't understand the step there, but because we have 3 lots of this plus a lots of the same thing, we can go 3 plus a lots of the thing. So we can turn from this step into that step. Now we're going to do the exact same thing down here. So we'll put them into brackets, 2ab plus xa plus 2cb plus xc. We'll factorize. So we're going to get a out the front of 2b plus x plus c out the front of 2b plus x, and then finally a plus c of 2b plus x. Okay, so that's the exact same process and just another example. Now there's some questions I'd like you to have a go at. So first, can you have a go at question 1?